In an earlier video, I showed you how to configure an op-amp as a non-inverting amplifier. But there are many more things you can do with an op-amp. Today I'm going to show you the op-amp comparator and a fun demo circuit too.
Hello!
So let's say you've got an LM324 quad op-amp that you bought from Radio Shack, Jamico, the Cuban Black Market, whatever. And let's power it with a 9-volt battery. And let's say you've got two different voltages on the inverting and non-inverting terminals of the op-amp. Let's label them V plus and V minus. If V plus is greater than V minus, the output of the op-amp will shoot up to the positive rail of the op-amp's power supply. In this case, that's 9 volts. Actually, because op-amps aren't perfect, it'll be slightly less than that, but 9 volts is close enough. If V plus is less than V minus, the output of the op-amp will go down to the negative rail of the op-amp's power supply. In this case, that's just 0 volts at ground. And that's basically how a comparator circuit works. So let's do some numeric examples. In this situation, 5 volts is greater than 3 volts, so the output of the op-amp goes high to 9 volts. Swapping those around, now the V minus voltage is greater than the V plus voltage, so the op-amp outputs 0 volts. Now it's important to realize that comparators are really sensitive to voltage differences. Let's say V minus is a very precise 2.500 volts. If V plus is 2.51 volts, the output will go high. If V plus is 2.49 volts, the output will go low. Alright, I think you get the idea, so let's build a comparator in hardware and get it to do something. Let's power this circuit with a regulated 5 volts so that all the voltages are guaranteed to be stable over time. On the inverting terminal of the op-amp, I'm going to put a voltage divider that will give me a reference voltage of 0.45 volts. On the non-inverting terminal of the op-amp, I'm going to connect the output of a potentiometer. The value of the potentiometer doesn't matter, I'm just using it as an adjustable voltage divider, so I can vary V plus from 0 volts to 5 volts and see how the comparator reacts. And on the output of the op-amp, let's put a resistor and an LED. As I vary the voltage at V plus, it goes higher and lower than 0.45 volts. This toggles the comparator's output high and low, which turns the LED on and off. On the oscilloscope, the yellow line is the constant 0.45 volt reference, and the red line is the voltage that I'm creating with my potentiometer. When the potentiometer voltage is greater than the reference voltage, the LED turns on and vice versa. Now there's no reason why you're limited to using a potentiometer as a voltage source here. You could use an audio signal, a voltage from a photovoltaic cell, maybe a voltage from your car's RPM meter, whatever you want. And of course, you can make V minus whatever voltage you want too, to serve as the comparator's tripping point. And on the output of the op-amp, you don't just have to power an LED. You could put a transistor there and use it to switch motors on and off, or toggle a relay, or whatever you want. Now let's move on to something a little more interesting. Let's make a clap-sensitive circuit. And no, I don't mean a hooker detector, I mean this kind of clapping. Here's the circuit diagram. The first part should look familiar. It's a microphone being powered up, then the signal goes through a high-pass filter to remove the 5-volt DC offset. Then it's going to an op-amp configured as a non-inverting amplifier with a gain of 101. So this will give us a nice amplified audio signal. By the way, I should mention that I'm only amplifying the top half of the audio signal here because I don't really care about retaining audio quality, I only care about how loud it is. Okay, so I take that amplified signal and connect it to the comparator on the right. When the amplified sound crosses the 0.45 volt threshold, the comparator will go high and it'll turn the LED on. Here's what that looks like on the oscilloscope. And of course, there's nothing stopping you from changing the threshold volume. If you add a potentiometer at V minus, you can adjust the threshold voltage to make the circuit more or less sensitive to sound. Now, the only problem with this circuit is that it only keeps the output high while the volume is loud.
Hello! Hello!
As soon as it's quiet, it turns off. Now I can fix that by adding another circuit called a peak detector, and check out this next video to see how that works.